So we are saying we are considering equilibrium of a body on a rough inclined plane. It has a weight W lying on a rough inclined plane at an angle alpha. So the minimum force P1, which will keep the body in equilibrium when it is at a point of sliding downwards, is going to be P1, and we are going to derive an expression. This expression is going to be paramount in a number of scenarios. So we are saying at a point of sliding downwards, this frictional force will act upwards along the plane. So we are saying the frictional force will act there. So maybe we call it F1. So we are saying in this case the frictional force F1 is equal to nu R1 will act upwards as the body is at the point of sliding downwards in the figure above. Now resolving forces along the plane. If we resolve forces along the plane, what will happen? We see that here we have W cos alpha, okay, and we also have another force there. We have another force here, which is W sine alpha, okay, due to this W acting at an angle alpha with this normal reaction, a line of action. If we extended the line of action of R, we shall find that it is going to experience an equal and opposite force due to this weight. We say the weight is the one that results into an action on the surface where it is resting. Then the surface where this weight is resting is going to react with an upward force that we are calling the reaction. But since we are talking about the inclined plane, then this force R is always going to be perpendicular to where the body is lying. So we are going to resolve directly along the line of action of R, and we shall get the component of W, which is going to be W cos alpha. When we resolve along the plane, then we shall find that the component of W is going to be W sine alpha. So resolving forces along the plane, we will see that F1 plus P1 is obviously going to equal to W sine alpha. Okay? Now, at a point of sliding downwards, then F1 is equal to nu R1, and this is equal to, we shall find that this is the same as R1 tan phi, much as we can stop it at this level, but we are going to bring our new R1 in here so that we have new R1 plus P1 is equal to W sine alpha. Okay, we call this equation 1. That is when we resolve along the plane. When we resolve perpendicular to the plane, now resolve perpendicular to the plane. So when we resolve perpendicular to the plane, we will see that R, okay, this R, maybe we call it R1, and W cos alpha, okay, they shall be together. So W cos alpha must equal to R1. Okay, so when we bring it in here, we will see that this is a 2. Okay, let me call it star. So I put star in equation 1. This was our equation 1. So what will that be? Our new times W cos alpha will equal to okay, I'm supposed to add there P1. So I'm substituting it in here. New times W cos alpha plus P1 should equal to W sin alpha. That's what I'm trying to do. So plus P1 is equal to W sin alpha. So P1 plus new W cos alpha is equal to W sin alpha. That is our equation. And our P1 will therefore equal to W into this sin alpha minus new cos alpha. Okay, I want to introduce a concept. If I multiply this sin alpha by cos phi, what is it going to be? I want to bring in a concept of sine into alpha minus phi. This is equal to sine alpha cos phi minus sine phi cos alpha. Okay, so if I bring it in here, then if that one happens, I'll be able to look at that expression here and summarize it as sine alpha minus phi. So let me multiply both sides by cos phi. So P1 cos phi will equal to W into sine alpha cos phi minus new cos alpha cos phi. Okay, what does that mean? I already said nu is equal to the same as tan phi, because the coefficient of friction is the same as tan angle of friction, and this is equal to sine phi divided by cos phi, because a tan is equal to sine out of cos. So if I substitute it in here, what will happen? I'll have P1 cos phi equal to W into sine alpha cos phi minus, I put in sine phi here divided by cos phi times cos alpha times cos phi. What does that mean? I can cancel out this cos phi with this cos phi, so that I remain with P1 cos phi equal to W into sine alpha cos phi minus sine phi cos alpha. Does it in any way resemble what I gave you up there? Sine alpha cos phi, then sine phi cos alpha? Yes. So if it resembles, then I'll say, but sine alpha cos phi minus sine phi cos alpha is the same as if I had sine into alpha minus phi. So I put it up there. I say P1 cos phi will equal to W sine into alpha minus phi. Therefore, P is going to be W sine alpha, sine into alpha minus phi, everything out of cos phi. So from today and onwards, if we have a force that is acting on a body on an inclined plane, if that force is going to act in such a way that we keep the body in equilibrium at the point of just sliding downwards, then to get that force, given the angle alpha, given W, and the coefficient of friction, we are able to use this formula, W sine into alpha minus phi out of cos phi, to determine that minimum force P1. So that's how we do that.